is that I no longer have the searchdb inside here. So the data wasn't persisted and it doesn't survive me deleting the container. Now, if in your case you still have data in your database and you do want to remove it, then what you can do is take a look at Docker volume list. And inside here we can see the volumes that have been created along with their names for the persistent data. And what you can do if you did want to actually remove the data there is say Docker volume rm and then paste in the name of the volume that you wish to remove. And if I wasn't using it, then I would be allowed to delete it. But that's how you can delete a volume. If your Docker is working differently to mine and you did retain your data even though you wanted to delete it, then you can use this approach. Anyway, mine is empty. I've confirmed that because I've seen the MongoDB connection and it does not have that searchdb. I'll need to start the auction service first of all, so I'm just going to use .NET Watch to start this. And then I'll need to start the search service, and what we should see is that we populate our database with the auctions from the auction service. And we get 10 items returned from the auction service, and what we should find is that if I refresh, then we've got the searchdb and we've got the items and we're back to 10 documents in that database. Now, you're probably thinking there's some flaws with this approach, and there is. And we're going to investigate those flaws in the next lesson, but I did just want to look at the happy path first of all, and in the next lesson we're going to take a look at what can go wrong. Okay, so we've done a bad thing really. We've used synchronous communication in our microservices, and obviously for reasons that we'll discover as we go throughout this course and reasons that you've probably thought about already, there's many reasons why we'd not want to do this kind of thing. Because HTTP, by nature of how it works, is we send a request and we have to wait for a response or for it to crash or something goes wrong. And what we have now is not really an autonomous microservice, because now we've got a reliance, a coupling, if you like, with our auction service. And just for example's sake, and in fact, let's just stop our services. I'll stop the search service, I'll stop the auction service, and what I'm also going to do is just run docker compose down, I don't need -d, just docker compose down, and that's going to remove our containers from Docker. And because I can't get persistent storage to work, at least on my machine, let's take a look and we'll just use anonymous containers for this. So let's go to, or anonymous volumes they're referred to. And an anonymous volume looks like this. We just take out the name of the volume and we just give it a file path. And we'll remove this volumes from here. And this means the behavior for yourself and myself is going to be consistent. And deleting the container means we also delete the data associated with that container. So I'm just going to restart Docker, and let's just clear this window and say docker compose up -d, and we've got our containers started, and now they're just using a slightly different type of storage inside Docker. And when we do delete a particular container, that means also the volume goes along with it, which is fine for what we're doing in development. Obviously you wouldn't want that behavior in a production environment, but we would not be using Docker Compose anyway in a production environment, nor would we have our databases running inside containers either. We'd use something like a cloud database provider which offers high availability, resilience, and all of that good stuff, rather than running it inside a container. But anyway, now we've got our MongoDB up and running. It's now empty of data once again. If I refresh SearchDB, then it is now empty. And that would be the same for our PostgreSDB as well. But obviously, in the case of the auction service, then we just need to restart it and it gets its data back. But supposing we're in a situation where we do start our search service and our auction service is not available. This is one of the problems with what we're doing. So I'm just going to execute .NET Watch and see what happens. well, clearly we get an exception. Our application hasn't suffered a catastrophic failure because it is running. But what happened is that we do not have any data in our database because the HTTP request failed. And we've got a connection refused, of course, because we do not have our auction service running. And if I go and make a request in Postman to go and get all the items, then of course I'm going to get no results back because we have no data. Now, supposing the auction service recovers from its failure and we run it again, then what's going to happen with our search service? Well, we've got data in our auction service, we've confirmed that, but of course our search service is not in sync with our auction service. Now, we know that if we restart the search service, then it's going to make that HTTP request again, and it's going to go and get the data and populate that database. But is there a better approach? Well, yes, there is. And what we can do is add a bit of resilience into our HTTP request inside our search service where we've got this. We would like this to repeat until such time as the data is available and we can get a successful response back from the auction service, even if it's down for some time. Now, there is an approach we can take using HTTP polling, which means our request is going to repeat and repeat and repeat until such time as it succeeds. And that's the rather simple approach we're going to take to dealing with this kind of situation. We're catching the error inside here, so we're not failing our application. Our application is still going to run, but clearly if we're relying on our auction service to provide the data, then we need to keep calling that service until it's available. Now, we're going to install a package that's going to help us make this kind of request based on the response that we get back from this particular service. So we're going to go to NuGet, and we're going to open a NuGet gallery, and the package we want to look for is Microsoft.extensions.http.poly. And this is the one we're going to go ahead and install into our search service. So we'll go ahead and install this. And once that has installed, then we can go and make use of it. So inside the program class then, just below the run method, we're just going to create a static method inside here that's going to allow us to create a policy, and we can handle the response based on what actually happens. Now, we're going to look for an exception in this case so that we can do something if we do get an exception, such as the one we had, the connection refused. So we're going to make a static method inside here, and this is going to be return an iasync policy. And we get this from poly. And the type of response we're looking for is the HTTP response message. This is what we get back from an HTTP request, and we'll call it get policy. And in here, we're just going to say, we'll use an arrow, and we'll say HTTP policy extensions. And what do we want to do? We want to handle a transient HTTP error. And if we take a look at the description, this builds a policy builder to configure a policy which will handle HTTP client requests that fail with conditions indicating a transient failure. Now, transient failures are things that hopefully will be not failures in the future, as we don't want to keep repeating the same request which is not a transient failure, as that's always going to be an exception. That would be a logical exception. For example, if we were trying to get something that returns a null reference exception, that's always going to be a null reference exception unless something changes in the code. So these handle transient HTTP errors. If we get a connection refused, such as we did, then this is going to handle that type of error. We can also handle other type of results as well that are not exceptions, and we could say, for example, and this isn't going to do anything for us, but I'm just putting it in here just as a simple example. We could say that we also want to handle, and let's say we say message goes to message.statuscode equals or double equals HTTP status code, and for whatever reason we also wanted to do the same thing in the case that we got a not found request. Now that would not be a transient error, because if it wasn't found once, then it's not going to be found twice, 3 times, etc. But it's not going to do any harm. I just wanted to add another simple example inside here. And then we can specify what we want to do. And in this specific case, we want to wait and retry forever async. We want to keep trying until such time as the auction service is back up. And at that point, we can then make the request successfully and populate the database with some data. So in this case, we're going to say underscore and add an expression here, so we can say time span from seconds, and just for example's sake, I'm going to say 5 seconds. Or no, 5 seconds feels too long. I'm going to say 3 seconds in this case. So this is what's going to happen if our auction service is down. Then we're going to handle the exception, and we're going to keep on trying every 3 seconds until the auction service is back up. At that point, we'll be able to make a successful request and we'll stop trying. Now, this get policy, we need to use this with our service, and we'll use a period and we'll say add policy handler, and we'll pass in our get policy that we've just created along with the parenthesis so that we execute that. Now, if we go back to our command line, and let's see, we've got the auction service that is up and running. I'm going to stop that. I'm also going to stop the search service, and we're just going to repeat what we did earlier. And in order to repeat what I did earlier, I'm also going to need to delete the MongoDB. So I'll just go back to the Docker containers and I'll just use the delete and delete forever. And that means our MongoDB is now going to be empty. And then I'm going to start the search service, and please make sure the auction service is stopped at this point. And my auction service is stopped. So what we should find is that when we start our search service, then we're not going to see an exception, but what we should see is that we're going to start to poll the auction service until such time as it has started. But of course, I don't have a MongoDB, so that's going to time out until it stops. I need to actually run docker compose up-d so that we do have a MongoDB server, because our search service will not start without the database that it needs. And let's give this another go. So what we see now is that every 3 seconds or so, we're going to send a request to the auction service to try and get the auctions. Now the date isn't populated with a date because we don't have anything in our MongoDB just now for the items. And this is going to keep going forever. Well, not forever, because I'm going to start the auction service again now. And I'll just execute .NET watch here. And what we'll see is once this has started, is that we'll see that the request finally completes. We get the 10 items returned from the auction service, and everything looks good. But there is a scenario where this is still not good enough actually, and if I go ahead and stop the auction service once again, and let's go back to the search service, and I'll just stop this and restart it. And of course we're going to hit our exception again because it's going to make that HTTP request. But what we'll find is that our application says it started, or at least it looks like it started. But if I go to Postman and make a request to go and get all of the items, then I've got a connection refused because my search service has not actually started. It's still waiting for the auction service to come back up and running. So we need to make another small adjustment inside our code here. And what's happening here is we're hitting this line to initialize our database, and then we're moving into this code so it can retry the request. But we're never actually getting to the point where we've hit this particular method to run our application. So we need to make a small adjustment here. And what we can use is we can hook into the app lifetime event. So I'm going to say app.lifetime just underneath the map controllers and say application started. And I'm going to register and say async and add parentheses, add the arrow function. And then I'm just going to move the code that I've got here, the try catch block, inside